Hello, I'm Steve Lagakos, a friend and colleague of Marvin Zelen for 25 years.
And I'm Louise Ryan, also one of Marvin's friends and colleagues.
Before meeting Marvin, we thought you might want to know a little bit about his earlier years and how he became interested in statistical science. Marvin's youth was spent in Wilmington, Delaware, and in the Bronx, New York. His father operated a pool hall at one point, but the primary family business was a candy shop and an ice cream parlor adjacent to a movie theater. Marvin helped out in the store, although his main interest revolved around sports, especially softball played on the hard surfaces of urban school playgrounds. His parents were good with figures, a talent later discovered in various relatives around the world. Marvin was also a good student. He finished 1 year at City College of New York before being drafted into the Army in 1945, at the age of 18. He was assigned to the Weather Service along with other mathematically talented recruits, including future statisticians like Sam Greenhouse and Ingram Olkin. Marvin spent time in Greenland and in Iceland, making weather observations and defending our coasts. When he was discharged at the ripe old age of 19, Marvin was able to use the resources of the GI Bill of Rights to finance his education.
Marvin returned to City College and switched his major from engineering to mathematics. He became interested in the theory of probability and decided to pursue graduate studies at the University of North Carolina. At that time, the statistics department at UNC was headed by Harold Hotelling. In addition to Hotelling, the faculty included Herb Robbins, Wassily Höfting, who later became Marvin's advisor, and R.C. Bose. Marvin earned a master's degree at UNC and then took a job at the experimental towing tank at the Stevens Institute of Technology. It was soon clear, however, that analyzing data from tests conducted on ship models in an experimental towing tank was not what Marvin wanted to do with his life. He started to look for a new job and eventually accepted a position at the Statistical Engineering Lab of the National Bureau of Standards. To this day, he considers taking that position one of the most fortunate things that ever happened to him. On his first day at the NBS, he was told by the head of the Applied Math Division that his job was to do good research. So, he sat in an office barely bigger than a clothes closet and did just that. He benefited enormously from the friendships and stimulation from such noteworthy statistical colleagues as Churchill Eisenhardt and Jack Uden. While at the Bureau, Marvin was also encouraged to get a PhD. He and his wife Thelma began saving money with the intention of returning to UNC. Thelma was taking graduate courses at night at American University, and Marvin used to sit in the American University library doing his research while waiting for her. One day, Jack Uden suggested that perhaps instead of sitting in the library at American University, Marvin should sit in a classroom and get his PhD. Well, Marvin thought this was a great idea. So, he kept his position at the MBS, but also enrolled in the PhD program in statistics at American University. After completing his doctorate, he accepted an offer from David Blackwell to join the stat department at Berkeley as a visiting associate professor.
Academia began to look good to Marvin. After returning to the National Bureau of Standards for a year, he took a position at the University of Maryland, where he stayed for 1 year before moving to Madison, Wisconsin to join the staff of the Army Math Research Center. The 2 years in Madison were important ones because Marvin began to think about the role of statistics in biomedical research. He had opportunities to talk with geneticists, oncologists, and other scientists about their research problems, and he decided he'd like to try his hand at applying theoretical knowledge to solve practical problems in biology and medicine. Not long afterwards, he received an offer to head a biostatistics and applied mathematics group at the National Cancer Institute, which he enthusiastically accepted. He spent 4 years with the NCI, with one of these spent visiting the Imperial College of Science and Technology in London as a Fulbright scholar. While in London, his interactions with David Cox and Peter Armitage no doubt heightened his interest in statistical issues in biology and medicine. Back in the States, the lure of academia became even stronger. After weighing several options, Marvin accepted an offer from Seymour Geiser to come to the State University of New York in Buffalo, and to help build the Berkeley of the East. So off Marvin went to the Nigro frontier, where he formed the Statistical Laboratory, or Stat Lab as it was called, within the Department of Statistics. The Stat Lab became the statistical center for several large cancer clinical trials groups, including ECOG, the Eastern Cooperative Oncology Group, the VA Lung Group, the Radiotherapy Oncology Group, and the Ludwig International Group. Soon there was an enormous need for well-trained statisticians to become involved in the design and analysis of cancer clinical trials. The year was 1970, and the youth of this country were into activism and idealism.
Well, before long, the Stat Lab was attracting a great crew of young statisticians, people like Jack Kalfleisch, Stuart Pocock, Ross Prentice, Steve Lagarkos, Rich Gelber, Dave Schoenfeld, Jim Hanley, Colin Begg, and many others. After their training in mathematical statistics, they were all ready to jump headlong into serious collaborative work in cancer clinical trials. Marvin's 10 years at SUNY were years of incredible change in the field of biostatistics, in no small part a result of the enormous activities in clinical trials that were spawned in Buffalo. In 1977, Marvin accepted an offer to head a new division of biostatistical and epidemiology at the Dana-Farber Cancer Institute and to become a professor of statistical science at the Harvard School of Public Health. This move was noticeable because he brought his entire group of young biostatisticians with him who were appointed as junior faculty at Harvard. This move more than tripled the size of the biostatistics department at the Harvard School of Public Health at the time. A great deal of the credit for this transition goes to Fred Mosteller, chair of biostatistics at that time, who convinced Marvin to come to Harvard. Even more, he convinced Harvard to accommodate Marvin's team of biostatisticians. A few years later, Marvin took over as chair of the department. He remained chair for 10 years, during which time the department continued to grow and to prosper.
Louise, I have many fond memories of those early years, especially the migration of 15 or so of us from Buffalo to Boston. The thought of moving to one of the major medical centers in the country filled us with both awe and trepidation. Marvin instilled in us a great sense of enthusiasm and confidence that we would flourish and enjoy our new situation.
Yes, Steve, I wish I'd been around in those Buffalo days. It must have been an exciting time. I didn't meet Marvin until 1983 when I started my postdoc at Dana-Farber. By that time, ECOG was in full swing. I've always been impressed by Marvin's ability to sift through scientifically complex issues to get to the fundamental questions of interest. Marvin has stepped down as head of ECOG's Statistical Center now, but we still often hear the clinicians at our group meetings speaking wistfully of the days when Marv Zelen was around. Anyway, enough of this. I think it's time to meet Marvin.
I'm Dave Harrington, and I'm here with L.J. Way to talk with Marvin about the field of biostatistics, the training of students, clinical trials, and other areas of importance to the biostatistical community. Marvin, when did you first become interested in statistics?
Well, I went to school at City College of New York, and in my junior year, I took a course in probability and statistics. And the course was taught by a graduate of Iowa State, which was one of the leading centers in the country at that time in statistics. And I found the subject really coming alive to me because I spent most of my youth on the streets of New York, gambling a lot, playing 21, pinochle, poker, betting on lots of sporting events. And this subject was the first one I'd taken in college that really was real to me.
It sounds like the early beginnings of probability theory with the study of games and gambling. Who were some of the people, Marvin, who were influential early in your career?
Of course, the faculty who I studied with at the University of North Carolina had a lot of influence on me. They had a wonderful faculty, Herb Robbins, Vasily Hufting, who became my advisor, R.C. Bose, who interested me in the design of experiments, S.N. Roy, who used to teach multivariate analysis. Then I got this great job at the National Bureau of Standards, and that was quite important in my career. And I was like the youngest kid in the whole place, so everyone was very kind, full of advice, giving me lots of opportunities. And Churchill Eisenhart was head of the group. Jack Uden, one of the most brilliant statisticians I'd ever met. Joe Cameron, who was a great consultant, widely used throughout the Bureau, taught me a lot about consulting. And my friend Bill Connor, who was one of the leading people doing research in the design of experiments, who had a premature death.
Marvin, who were some of the statisticians who were influential early in your career, and how did they help you?
As I indicated, they were very kind to me. Churchill was getting all kinds of invitations to do book reviews, write expository articles for various encyclopedias and compendiums. He never could get around to it, and he always used to ask me to help him. So here I was, a very young fellow, barely out of school with a master's degree, writing the book review of Cochrane's book on sampling theory in science. So I had opportunities like that many times.
It sounds like you got started with people that had very generous spirits. When did you become interested in biostatistics?
I had spent the early part of my career involved in physical sciences, and then I took a post at the Army Research Center at the University of Wisconsin. It was like a lifetime fellowship. I had lots of time to talk to people, to think about new problems. And while I was there, Ed Gein, who was at the National Cancer Institute, came to visit me and presented me with a problem on clinical trials. And out of that, George Weiss, my old collaborator, and I developed the ideas of semi-Markov processes as applied to clinical trials. Unfortunately, we only kind of published that about 5 or 6 years after we discovered the ideas. But there I met up with Jim Crow, a famous geneticist, Charlie Heidelberger, who discovered 5-fluorouracil, which is still a leading treatment for GI cancer. And Charlie was always appalled at the way 5-FU was evaluated. But that really excited me. These problems very interesting. I found just sitting in my office at the University of Wisconsin getting a bit dull.
What were some of the statistical problems that captured your interest?
Nearly all the problems came from my contact with real problems. Turning to biostatistics, I became very interested in survival methods, especially when you had covariates. And I published a paper with Polly Feigl, which is one of the early papers on dealing with this subject. Of course, we could only do the problem when the survival was exponential. Later on, David R. Cox did this very elegant paper on proportional hazards models. When I was at the Bureau, I became interested in the theory of reliability, life testing, and that carried over when I got interested in biostatistics and got interested in survival methods. At the Bureau, I was always involved in planning experiments and became really quite an expert in design of experiments and did many papers on the subject.
I remember I was a graduate student in Wisconsin. I was doing my thesis research. The research actually was based on your 1969 famous paper in JASA, Play the Winners Rule, which is a very unconventional treatment allocation rule for clinical trials. And also your paper, Exponential Regression in Survival Analysis, published long before the Cox proportion hazards model, has become a classical reference in survival analysis. I just wondering if you can make more comments on this, how you motivate this kind of research.
As you know, I have been involved in the physical sciences in my early career, and I became quite knowledgeable in design of experiments. But then when I turned my attention to the biostatistical area, biomedical sciences, there was a new feature in planning studies, especially dealing with human experimentation. And people were very concerned about the ethics of experimentation, because if you're comparing 2 or more therapies, and one was really the best therapy, you'd have some people getting poor therapy. So the idea was to plan a way of carrying out studies so that you tried to minimize the number of people on the poor treatment. And that was the play the winner rule. No matter how stupid the investigator would be or the statistician advising him, it would always turn out that if there really was a bad treatment, very few patients would be on that treatment. And that kind of opened up a whole new area for me dealing with ethics of human experimentation.
You also introduced a very interesting, but in my opinion, is a little bit controversial, so-called random consent in clinical trials. Could you comment on that?
Yes. Well, as you know, I've argued with ethicists for many years on what I had proposed. And let me give you the setting. There are federal regulations governing human experimentation. And at the time, the regulations said that you had to get patient consent whenever one departed from the accepted norms of treatment. At that time, one of the cooperative groups was carrying out a major study comparing radical mastectomy with the tumorectomy. Tumorectomy is just removing the tumor. Very few women would go on that study. So that's when I came up with the idea of randomized consent. Randomize the women without their knowledge. Those who were assigned to radical mastectomy, that's what they had expected to get. That's what they received. Those who were assigned to tumorectomy, that was really a departure from the normal practice, and consent had to be obtained. They implemented that. The accrual was raised by a factor of 10 to 12, became a successful study, and out of that they found that the survival was about the same whether a woman had a radical mastectomy or a tumorectomy. And later on, the feds changed the regulations so that one couldn't use that in the United States. They said that if a patient was involved in a clinical trial, consent had to be obtained.
Marvin, how do you feel about the fact saying we should not use this random consent procedure these days?
Well, I didn't like the change in the regulations. I thought the earlier regulations were very fair. The ethicists, however, felt that anyone involved in a clinical trial should know about it and consent be obtained. I developed some other modifications of the randomized consent design, where essentially people were assigned without their knowledge to perhaps one or of two treatments. Then they were approached for consent. They were told what treatment the physician would like to give them, and they either agreed to receive that treatment or there's a negotiation about some other treatment. Now here, the patient in advance knew what therapy they were going to get. The conventional way of randomizing people was that patients are approached, the possible treatments are described, they do not know what treatment they're going to get, and they have to give consent in advance of knowing the treatment. I think my way is much more suitable for patients, and I was kind of surprised that more clinical trials hadn't adopted this method.
And we know these days the mammogram for breast cancer screening is a hot topic. Can you make a comment on this?
Just to show you that the old problems never die, my first paper in this area was in 1969, where Manning Feinlieb and I showed that length bias sampling was important in screening. The problems kept percolating along until the early 90s, when I became very interested in how you space examinations to get maximum benefit, and that was the paper that you just discussed.
Right.
Well, I've worked on two recent papers with two very outstanding postdocs. We have a paper in press with Dr. Ping Hu, which lays the foundations for how to plan these early detection trials. Early detection trials have not been planned very well because they've used the ideas of therapeutic trials. But early detection trials have features that never arise in therapeutic trials. How many exams do you give people? What's the spacing between exams? What's the relation between age and the disease population? And I think that that might help in the planning of future trials. With regard to the mammography, for women under 50, the public debate hasn't really examined the data. There is no data showing advantage to women under 50. On the other hand, are we to believe that women over 50 benefit, but if you're 49, you don't benefit? Looks kind of stupid.
Right.
And really, 50 is just a surrogate for menopausal status. There's only been one trial addressing the issue for women under 50. It showed no benefit. On the other hand, from our calculations, it would take an enormous trial to show benefit. And I doubt if there will be such a trial in my lifetime. On the other hand, with one of our postdocs, Sandra Lee, we have a paper that we're about to submit which models the whole disease process and indicates what ages should benefit if you're going to set up a public health program, and what's the spacing between examinations.
I'm just wondering, what do you think about the future of this direction of biostat research?
That's a big question. I'm glad you didn't ask me this a long time ago, because you'll see how wrong I've been. But as I tell all my students when they ask for a good research topic, I say take something that interests you and try to stress new ideas and innovation. You know, it's better to polish a rough diamond than to polish a stone. But I think there are lots of emerging new areas in biostatistics that haven't really drawn too much attention, and I'll just mention two of them. One is quite obvious, is the Human Genome Project, probably the most important project in biological sciences of this decade and of the next 2 decades. Lots of statistical problems there. Also, with the widespread use of computers, all kinds of databases are being collected, which might help us know more about our health programs in this country as well as other countries. But there are no quality control in most of these databases. And if we're going to use them effectively, we have to develop new methods which are very robust and even work when the quality of data is not what we'd like to see.
I still remember I was in Wisconsin back in '75 looking for a job. My thesis advisor, Steve Stigler, told me if I want to be a real biostatistician, I should go to Buffalo, SUNY Buffalo, work for Marvin Zelen. I wonder, what is unique about Buffalo program at that time? Can you comment on that?
In Buffalo, when I first came there after working at the NCI, I somehow became a bit disenamored with statistics in general and felt that it was not being used in an important way. And then decided deliberately to try to have a program where statistical science would be used in some important project. What we needed is a project with lots of fluctuation, lots of variability, and something that was of great public interest. And I decided that human experimentation would be important. And I was also interested in cancer still, so I got together resources to help carry out clinical trials in cancer. Couldn't do it myself, of course, so I recruited a group of very bright young people just out of school. And I think when I hired them, I didn't realize how lucky I was. They were smart, enthusiastic, lots of energy, and it was an exciting time. And in Buffalo, we started to develop the methodology of clinical trials along with our clinical friends. And we became a center and received a reputation which I don't know if we deserve, but it attracted lots of other people.
Marvin, one of the interesting parts about building these academic programs, both at Buffalo and later at Harvard, is the need for strong faculty. You talked about your early efforts in hiring LJ. I wonder if you could tell us how you foster faculty development once they've been recruited into your programs.
Well, I had a peculiar way of dealing with the faculty. I've been chairman of academic departments, and I've been head of laboratories and had lots of responsibility over people. And I always took the attitude that I was a servant of the students and faculty. And whatever would advance someone's career, I thought that was always in the best interest of the program. And I think that the people really appreciated having someone in authority trying to look out for their best interests. And in all of our groups, I think morale was very high. And if you're expecting intellectual work out of people, no matter what their status, I think you have to do all you can, respect them, help them, make the wheels turn.
Now, some of the projects that you are most known for, primarily the cancer clinical trials, have a long time to mature, involve considerable collaboration and effort on the part of our statisticians. Does the tenure system as we have it today foster that work and collaboration and support our junior faculty in those efforts?
It's a very delicate question. We have many centers in university environments which are doing fine work educating students in biostatistics. But the reward scheme in the universities does not reward the faculty for participating in major projects. The reward scheme is numbers of publications. Here we have major projects in clinical trials. What's the best way to treat breast cancer? What's the best way to treat GI cancer? Does a particular therapy really prolong survival in leukemia? These studies take a few years to mature, to accumulate patients, to follow up people, 1 year, 2 years to plan. The results are not likely to come about till perhaps 6 to 10 years after someone thought of the idea. When one of our colleagues devotes his or her academic time to the subject, they're surely going to be fired.
What would you recommend to department chairs to help nurture that work on the part of their faculty?
I think there has to be some kind of understanding that if people are going to be involved in long-term important projects, that they will be rewarded if one can show that their intellectual work is first class. I think that even if the projects don't turn out well, that if we don't find a cure for cancer, the quality of the input is very important. I think also that university chairmen, senior faculty should go out of their way to provide opportunities for younger faculty to show what they can do outside of these long-term projects. That means they need free faculty time to develop their own research program, mentoring, and everything that would promote enhanced academic scholarship.
Now, those activities come in the context of biostatistics departments, which are often largely funded through government grants. Does that federal support and that grant system help or hurt our discipline?
It does both. Without the federal support, we're likely to be shadows of what we are today. On the other hand, if one is going to put in grants which are very innovative, which depart from what people conventionally do, unlikely to be funded. So that's really a problem with regard to innovation. At the same time, some of our senior statistical colleagues are involved in major projects, large sums of money, and they find themselves doing mainly administrative work. Very brilliant people doing things they have little interest in, perhaps little talent in, but very responsible. And I think this is drawing lots of talent away from our profession.
What are you looking for when you recruit junior faculty into these academic positions and to work with these collaborative projects?
I think we're really looking for people who appear to be innovative, have their own ideas, well-trained, but they have to have a genuine interest in what we're doing. And if they don't have a genuine interest, it will never work out. And we've been lucky in most of our hires to have people who fit in that category. And I think all the people you've mentioned earlier have that common thread, well-trained, very enthusiastic about what they're doing, in fact, very excited about what they're doing, lots of energy, lots of responsibility for carrying out projects.
Marvin, I'd like to turn to some of your work with clinical trials. Many of the academic departments that you've been associated with also had a very strong component of work with multi-center clinical trials organization. I was wondering if you would say a few words about the role of those projects within the university.
Both in Buffalo and at Harvard, those large clinical trials tended to enhance the academic program. They served as motivation for much new research. Also, they provided opportunities for lots of young faculty and students to gain experience in the practice of biostatistics and important problems. Along the way, they not only used statistics in important situations, but they learned about all the other things that are required in a scientific project to make things go. How to design good data collection systems, quality control, review of data, interim monitoring and analysis. And these all percolated into the training of people on how to be good collaborators. At the same time, it served as a vehicle for promoting changes in the curriculum. You know, much of our curriculum reflects our own experiences in collaborations.
What are some of the pressures on faculty who work in that environment and work on those projects?
The university system is very hard on people who devote long times to projects without many publications. And this is the nature of most of these clinical trials. And now the academic environment is so competitive that I think in many instances the academic environment is even hostile to promoting collaborations of biostatistical scientists on clinical trials. And many of our younger faculty, I think, are beginning to be discouraged devoting time to these important efforts, and yet find that their academic seniors don't regard their activities as being terribly important with regard to the university goals.
Many of these projects are beginning to migrate outside the university to clinical research organizations, to government agencies, to pharmaceutical industries. What will be lost in the academic departments as those clinical trials are run outside the university?
Well, just to look back a bit on history, when I first became interested in biostatistics, the NIH was the center of the world, in my opinion. And then with the growth of clinical trials, many university centers grew up, very outstanding. Now, many pharmaceutical companies and other startup firms in industry are hiring outstanding young people who are carrying out these activities. So what's happening is a lot of important studies are being done outside the university environment. University environment may be hostile to some of these projects, and as a result, the flavor of important applications is going to not be in university departments of biostatistics. The faculty who may work on similar problems will only have experience secondhand about the real collaborations, and they'll be desk chair statisticians without getting their hands dirty on real problems, probably doing wonderful theoretical research, but on problems of little concern to people doing studies.
Would you tell us a bit about your work with ECOG and some of the people that you were associated with there?
The ECOG, for people viewing this, is one of the premier cancer cooperative groups in the world. Been in existence, I guess, over 45 years. I first became directly connected to the ECOG through my friend Paul Carbone. I was at the National Cancer Institute, met Paul Carbone, who was a young physician then, who later was elected to be the chair of the Eastern Cooperative Oncology Group. He asked me if I would help him with the statistics. Not knowing better, I agreed. When I said not knowing better, I thought I knew what to do, but of course I didn't have the foggiest idea what to do. So I agreed. And out of that friendship, and we developed a very close working relationship, and he, myself, his clinical colleagues, my biostatistical colleagues, worked to evolve the whole methodology of clinical trials. We were not alone in this, of course. There were other groups operating, but ECOG was very innovative. And a lot of this innovation was due directly to Paul Carbone or his encouragement. And I think all the people who've worked with Paul feel the same way. I think if I didn't have the contact with Paul, I would have quit a long time ago.
Marvin, why don't you take some time to tell us about some of the people you worked with in clinical trials in the early years of your career at the National Cancer Institute?
Well, at the NCI, I arrived there in 1963, and I didn't really know very much about cancer. I was interested in the problems. And the senior people there at the time were Jerry Cornfield. He had been at the Cancer Institute, but he was then in the Heart Institute. Sam Greenhouse, who was in mental health, formerly at the Cancer Institute. Marvin Schneiderman, who hired me at the Cancer Institute. Max Halpern, who used to be at the NIH and then came back. We all were together, even though we were in different institutes, discussing common problems. I was very much influenced by all of them, and I neglected to mention the great Nathan Mantell, who knew everything, and whenever I would mention something I discovered, he would say, oh yes, he knew about that 10 years ago, but didn't think it was terribly important. But it was a wonderful place to be, and they influenced me on the importance of being a scientific collaborator and not an ancillary biostatistician.
Rich Gelber, a colleague of ours at Harvard University, has been involved in clinical trials for more than 20 years. We asked Rich to comment on his research and his early experiences with Marvin.
I have devoted my entire career to collaborations with clinical investigators in cancer and AIDS, and am now a professor in the Harvard Medical School and the Harvard School of Public Health. I represent but one of hundreds of biostatistical scientists who are indebted to Marvin for his pioneering work to establish our role as co-collaborators with clinical and laboratory scientists. Marvin set the stage by articulating principles to foster high-quality standards and mutual respect for our professional contributions to clinical research. He demanded that we use our biostatistical training to advance our understanding of the risks and benefits of the therapies under study.
You make a comment about if the industry people tended to running trial themselves, the university going to lose the opportunity to do very interesting research in the future. I wonder, you have some recommendation in the future. How should we do this?
Universities and industry are going to join together more than they've had in the past. The university people need the contact with real problems in order to make their classroom teaching come alive and as a source for important research problems. You can't get this sitting behind your desk. You have to go out, talk to investigators, be part of all the scientific deliberations. At the same time, we in the universities have different goals than people in industry. People in industry want to get a therapy, usually a drug, approved by the Food and Drug Administration. They're willing to sink enormous resources to generate studies for that purpose. On the other hand, their submissions are enhanced and strengthened if they're working directly with university people.
What does our discipline bring to that scientific endeavor of a multi-center clinical trial?
I believe that our education is such that our people understand and know a lot about the scientific method. And it's not only the quantitative aspects of things, but just the logic of scientific method. I think that after a while, some of our very experienced people get so expert in the planning of studies, and Becky Gelman is one example, who's widely respected for her knowledge of breast cancer, that our statisticians are approached not because there's statistical advice that's required, but there's more broader advice on scientific method. I sometimes have given talks at medical meetings, and when I get off the platform, sometimes people come up to me and say, for a doc, you know a lot about statistics, thinking that first I know a lot about the subject matter. And I think that's what's happening to lots of statisticians.
Rebecca Gelman, Associate Professor of Biostatistics at Harvard University, is an expert in many areas of cancer research. Becky was a doctoral student of Marvin's and has been very much influenced by him. Here's what she has to say about the role of biostatistical scientists in collaborative research.
I first met Marvin the day before I started graduate school in Buffalo. I had applied to the Department of Statistics, but a secretary there claimed I wasn't on their list of incoming students. As I tearfully and frantically searched through my bag for the letters of acceptance and funding, she directed me to Marvin's office. He assured me that I had a scholarship to study statistical science. I was too relieved to ask what the science part meant. At the time, I guessed it referred to applied statistics. Today I think that to Marvin it means truly interdisciplinary research. He's made mathematical and conceptual contributions to the study of cell cycles, natural history of chronic diseases, and screening. But perhaps more important than any of the specific areas of study, he's promoted the idea of the statistician as an integral part of a scientific team, as a person who can abstract the fundamental features of a phenomenon and come up with new and testable models, as someone who can help young scientists find fruitful problems. I'm always running into non-statisticians who consider Marvin to be their mentor. For example, the man who built the first flow cytometry machine when he and Marvin worked in Washington, not to mention numerous oncologists, radiation biologists, and immunologists. We think of Marvin as a cooperative group statistician, but for 2 decades he's also been a cancer center statistician and has worked on methods for early phase clinical trials, laboratory and animal research, and community studies of cancer clusters. His students and junior colleagues have gone on to head a dozen other cancer centers, and Marvin served on the advisory committees of half a dozen others. So he's had a major impact on cancer center organization, funding, and attitudes of statisticians and non-statisticians. In the larger arena, Marvin's influenced the direction of research in several fields by serving on cooperative groups, federal task forces, consensus conferences, and review committees of all types. On the international level, he's advised statistical societies, even founded cooperative groups, and actively encouraged visiting scientists. He teaches his students that these are important activities of statisticians, that statisticians should care passionately about the quality of science, and that you need to take an active part in forums in which you are the only statistician present. In Buffalo, there was an anonymous note posted outside of Marvin's office that said, "Today the Stat Lab, tomorrow the world." As students watching the exponential growth of the 6 cooperative groups that Marvin was coordinating, we thought that note referred to office space. Now I think it refers to the world of science.
Staying with the issue of trials based in universities or outside the university, Marvin, you've worked actually both with university and not-for-profit centers, and in fact started Frontier Science and Technology Research Foundation to help foster your activities in clinical trials. Tell us a little bit about that organization and some of the people that were important to you there.
At the time, we were involved in these very large demonstration projects showing how important statistics would be in human experimentation. Had responsibilities for many clinical trials, hundreds all over the country, different parts of the world. Well, we needed support from the university administration. In space, we wanted them to reward our very good people, other than faculty, because to carry on these studies in a first-class way, you need data management help, outstanding computing, database administrators, a whole set of skills, administration, that academic departments don't normally encounter. Universities very resistant to reward these people. So when the president of the university I was at said that the faculty who do research cost the university money, and he preferred they didn't get grants, I became so enraged that I formed this nonprofit foundation to advance statistical science, Frontier. I formed it by loaning the foundation $100 for stationery. Today, it's a very active organization, having about 180 people with branches in Buffalo and in Brookline, Mass. What it's done is has worked very closely with universities over the country, and especially in projects relating to cancer and AIDS. For the viewers here, the Frontier Science is the key data management center for the AIDS Clinical Trials Group, which is the major government effort in finding new therapies for AIDS. It also is the data center as well as the administrative center for the ECOG Cooperative Oncology Group. Without Frontier, I don't think the ECOG would exist today in the same way. And what it illustrates is that for all of these complicated clinical trials projects involving hundreds of institutions, sometimes thousands of physicians, very complicated, that one needs a lot of support. Universities are often reluctant to give that support, reluctant to give space, reluctance to recognize outstanding achievements of non-faculty. That's where an organization like Frontier has played an important role.
Marvin, one of the things that we've learned today is that you in your role, both in academic setting and in clinical trials, have had to draw on a number of skills. You have done methodologic research, you've worked with government panels, you've helped train new people, you have written in substance areas and learned a lot about cancer. We have to presume that our biostatistics curriculum is where we prepare the next generation of statisticians to reproduce those activities. Let's talk some about the curriculum and curriculum development in the modern era.
Yes, thanks, Dave. I may like to add something in Dave's question. Marvin, I notice when we hire young faculty members, and we tended to hire people, they graduate from statistics department with a couple years postdoc training in biostatistics. We sort of shun away to hire people directly from biostat department. So that also, if you notice in our department, our faculty members, the majority, they also graduate from the statistics department. I'm just curious how we train the new generation of biostatisticians. And for example, if you go to extreme, can we actually abolish biostat department and just train the student, every student from stat department, then every student goes through 2 years biostat postdoc training if they are interested in biostatistics. Do you think that may work or not?
I think that if you want to have potentially outstanding biostatistical scientists, I'm not saying a biostatistician, I make a distinction. A biostatistical scientist is someone who uses probability, statistics, computing, mathematics to advance our understanding of a subject matter field. Biostatistician may do that, not quite clear, but biostatistician in the university teaches and does research, but not necessarily advance our understanding of subject matter fields. Now, I would prefer that we turn out biostatistical scientists. And if I was to make a remark on our own curriculum, and I'm sure this is true of nearly every biostatistics curriculum in the country, there's not enough theory and not enough practice. And I think our training programs would be enhanced if we did both more. Of course, this means that the training period gets extended, and it probably should be 5 or 6 years. Financial considerations make it difficult. So, as you know, we try to encourage most of our graduates to take a few years postdoc to fill in the training that we haven't properly done.
How much, for example, biology, do you think those biostatisticians should learn during their graduate program?
The problem came up before, and I had commented that in interdisciplinary activities, the people are expecting the biostatistical scientist to be an expert in quantitative methods. If we dilute the training by having the people take courses in subject matter fields, they're not going to get the same kinds of training that we could offer in place. On the other hand, the fields of potential application are so large that it's doubtful whether some courses in biology or specialties in medicine would be directly relevant. And it's been my own experience that if someone is well trained and works in a subject matter area, like, for example, in cancer, you get to know the area quite well, at least well enough to understand what the scientific problems are. And you may have real understanding of the processes. Taking a course only will familiarize somebody with the proper nouns and verbs at a cocktail party.
Do you think that need for subject matter knowledge makes a postdoctoral fellowship almost mandatory now for biostatisticians?
I think the need for the experiences in the practice of biostatistics makes the postdoc fellowship mandatory. Most of our own students are well prepared to carry out theoretical research. They have limited experiences, although there are exceptions, in participating in consulting collaborative activities. And I think using a postdoc to fill in that training would be a wonderful thing to do. It will certainly enhance their usefulness outside the university setting. Because if you think about it, most of our own students, and I think this is true in most departments of biostatistics, the young students don't take jobs in universities, they take jobs in industry. And we're not preparing them enough to take those jobs in industry. And in universities, people tend to be very conservative. And I think that the intellectual jump from theory to practice is a very big intellectual jump that few people can appreciate unless they've been involved in the scientific process.
Marvin, we've covered a great deal of territory today in these discussions. From your view, what has changed in biostatistics in the last 30 years? Where are we headed? What are our important problems?
Well, nothing ever remains still. It's clear that looking back over the past 30 years, computing has had an enormous effect on the kinds of research we do, the kinds of problems we attack. We use methods that we never dreamed we would use 10 years ago, much less 30 years ago, because of the computing power we have. What I see happening now is that some pharmaceutical companies, are beginning to join forces with academic departments in joint ventures. I would hope that that trend will continue. I think that's very important. It will benefit the academics, it will benefit industry. I think that the universities have to be much more flexible in the reward structure, or else we're going to find that important application areas are going to leave universities and be lodged in centers, as I mentioned earlier, as well as in various pharmaceutical industries, because the pharmaceutical industries are really hiring many biostatisticians, and they're hiring very outstanding young ones. And I think it's quite possible that the Center of Biostatistics can leave academic environment and be lodged in some of the industrial companies, but I would hope that that wouldn't happen.
Marvin, through those 30 years, you've been very directly involved in many of the changes in our discipline, both from an academic perspective and its role in society. What would you like to be best remembered for?
Well, first of all, let me just say that all research is transitory, and I doubt 10 or 15 years from now anyone would know what I've ever done as far as theoretical research goes.
I don't think that view is widely shared.
But anyway, I think what I would like to be remembered for is all the people that I've been my colleagues, that I've associated with, and who've had gone on to very nice careers. And I think that my students, my colleagues, really are my remembrance.